Hey boys and girls, it is Mr. McAndrew, the math coach, and we are back doing some math today. I wanted to go over some of the problems from yesterday in case you had some questions about it. I know this is definitely more challenging than what we've been doing, but this is really important, and I'm just going to ask you to hang in there and do your best and ask questions of your teacher when you have questions, and we'll get through it, okay? So yesterday you were given some equations and then the idea or expressions, and then the idea was to draw some like a model. Now I drew a bunch of models. You only needed to draw one model. So you may have drawn a number line, right, where you have 18 divided into groups or hops of 6, which would give you 3 hops. Okay, or you might have had a number line where you did 18 divided into 6 hops, right? 6 hops would give you, and then if you had 6 hops, you'd have to jump by 3, okay? You may have done it this way with equal groups, 3, so you've got 18 divided into 3 equal groups, which gives you 6 in each group. You may have done it this way. I didn't finish this one. You may have just done like an array, where you have 18 divided into 3 rows with 6 in each group. So there's lots of different ways that you may have done it. Just choose one, okay? And if yesterday you got confused or you struggled, you can choose one of the models today and you can finish it up, okay? So I think multiplication is a little bit easier and clear. But remember that the same model can represent both multiplication and division, right? Like this model shows 7 times 5, 7 rows of 5. It could also show 35 divided by 7 because there's 35 circles divided into 7 equal rows, okay? Here's a number line example. It's 7 hops of 5, so 1, 2, 3, 4, 5, 6, 7, and you land on 35. And that's a great way to learn your facts, right? So if you're like, okay, 7 times 5, what's 7 hops of 5? So you go 5, 10, 15, 20, 25, 30, 35. And I've done 7 hops of 5 and I got to 35. Skip counting. I'm sure your teachers are starting to have you do some skip counting, okay? There were some problems over here. Remember, just one visual model. If you're good at arrays, then use that. If you're good at number lines, then I would use that. So 2 groups of 4, you might have just done like this. Let's see, I'll just put circles in. All right, so you've got 2 groups of 4. 15 divided by 3, for that one I'll do a number line. Maybe you did that. If it's divided into 3, it could either be groups of 3 or 3 hops. I'll do 3 hops. So I did 3 hops. That would be 5, 10, 15, like that. Okay, and then down here I've got 7 times 5. I had that one over here too. Silly Mr. McAndrew. So so for 7 times 5, you already did one of them. So do a different model for 7 times 5, right? So if you did the number line, then maybe try an array, or you could try the area model, 7 groups of 5. So we draw 6 lines, 1, 2, 3, 4, 5, 6, and 4 lines, 1, 2, 3, 4. Area model is a little bit more challenging to draw, but the idea is that you just draw one in each. And if you like the number line, then use that. If you like the equal sets, then use that. Okay. All right. So if you need to finish anything up with this, please do that. And we're going to move on to today's work, which is today. There's only going to be 3 problems. That's it. Okay, because they require a fair amount of work. Because what we're going to do is we're going to take an expression like 3 times 8, and we're going to figure out which of the word problems or statements match the expression. So yesterday we were doing, if I give you an expression, what's a model we could draw to represent that? Today, I'm going to give you an expression and what's a word problem that would match it. Okay, so let's get started. Let's read along with together. It says, at Thanksgiving, just coming up, Yvette wrote this expression to find the total number of chairs she saw around tables in a dining room. So remember, you want to visualize what that might look like. What do the tables look like? There's chairs around it, right? And it says 3 times 8, or 3 groups of 8. So what do you think that might look like? So it says down here, which statement describes the numbers of spoons and tables Yvette saw? Okay, so let's look at the first one. It says, here, I'll move myself down here. It says, now, by the way, I gave you room for a visual model. You don't have to use it if it's not helpful, but you might want to draw something that helps you to see what's going on, okay? So it says, Yvette saw 3 tables and 8 chairs. How many chairs did she see? So does that help? Does that really describe what's going on, that there's 3 tables and 8 chairs? It says there's, let's see, it says that wouldn't be multiplication, right? It would just be 8 chairs. There wouldn't be multiplication. That doesn't make any sense, right? That wouldn't represent 3 times 8. 3 times 8 could be, let's see, 1 table, 2 tables, 3 tables. And there might be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 chairs around that table. And we'll put 8 chairs around this table. And we'll put 8 chairs around this table. So there's 8 chairs, 8 chairs, and 8 chairs. So that's a model that you can use to think about as we look at these. All right, the next one says Yvette saw 3 tables, and each table had 8 chairs around it. That's what we just drew, right? I mean, it could have been 3 chairs around. No, it doesn't really make sense. I think this is the only way it makes sense, right? Okay, so each table had 8 chairs around it. How many chairs did she see? That one seems to make sense. Let's check. Yvette saw 24 tables. How many chairs did she see? That doesn't make any sense. She didn't see any chairs if all she saw were 24 tables. Okay, now 3 times 8 is 24, but that doesn't make any sense. All right, last one. Yvette saw 8 tables and 3 chairs. How many chairs did she see? Well, that doesn't represent 3 times 8. That just says she saw 3 chairs. So the only one that makes sense is this one, right? That's the only one that makes any sense. She saw 3 tables with 8 chairs around each table. Okay? All right, let's go on to the next one. It says Thursday practice number 2. It just gives, all I'm giving you is an expression. 6 times 3. Now you could do a visual model if that helps you, okay? So there's 1, 2, 3, 4, there's 5 different scenarios. It says which word problem could be solved by using the expression 6 times 3. So the question is, when we look at these word problems, could any of them be solved using multiplication, 6 times 3? All right, so let's take a look. Okay, let's read the first one. It says Kate collects baseball cards. Each page in her collection holds 18 baseball cards. Okay, so she collects baseball cards. Each page holds 18. That's a lot. She has 6 pages in her collection. How many baseball cards does she have in her collection? All right, well, that would be if each, so each page holds 18, right? And she has 6 pages, so that would be 18 times 6. That's not 6 times 3, so I don't think that one makes any sense. All right, let's try this one. Joe has 3 boxes of model airplanes. Okay, so 3 boxes. I'm thinking of 3 boxes. I'm going to put it up here. 3. He's got 3 boxes. Each box holds 6 model airplanes. I'm going to put 6 in each. How many model airplanes does Joe have in the 3 boxes? So does 6 times 3 make sense to help you with that? maybe you've got 3 boxes, you've got 6 in each box. That might help. All right, so we'll put a question mark next to this one. Let's try the next one. Brad will cook breakfast, lunch, and dinner for his family for 9 days. How many meals will he cook? Well, that's not 6 times 3. That would be more like 9 times 3, right? 9 days doing breakfast, lunch, and dinner. It'd be like 9 times 3, so that doesn't make any sense. Let's cross that off. All right. This one says, Peggy is the line leader for her class this week on Monday, Tuesday, and Wednesday. So that's 3 days. So let's say she's got Monday, Tuesday, and Wednesday. Okay. She will lead her class line 6 times on each day. So 6 times on Monday, 6 times on Tuesday, and 6 times on Wednesday. Here, I'll draw a line here. How many times in all will Peggy lead her class line on Monday, Tuesday, and Wednesday? So this one seems to make sense, right? Because we have 3 days, or we could think of it as 3 groups, and there's 6 in each group, which would be, that would be more like 3 times 6 instead of 6 times 3. But it does sort of seem to make sense that you've got a 6, you've got a 3. All right, so maybe we're not sure about that one. All right, and the last one, Carrie, Gina, and Tom each have 18 pennies. How many pennies do these 3 have in all? Okay, in all. So that would be like, they each have 18 pennies. So Carrie has 18, Gina has 18, Tom has 18. That would be 8. That would be 3 times 18. That's not going to work. Okay. So we're back to this one and this one. So what I think, boys and girls, I think that both of these could work. I think it would have been better if instead of 6 times 3, it said 3 times 6. So let's write 3 times 6, because that fits with the way we've been talking about it. But if you did 6 times 3, it would still get you to 18, which is the answer to both of those problems, right? Joe has 3 boxes, with each box has 6 model airplanes. And Peggy is the line leader for 3 days, and each day she leads her line 6 times. So 3 days of 6 line leads. Whew, this is a lot of work, boys and girls, right? All right, and I'm doing a lot of the work here, so I hope you're following along. All right, this is the last one. I would like you to try this one on your own, okay? It's not quite as word heavy. There's less words. Okay, it has to do, so it says 30 divided by 6. Okay, and then you've got 1, 2, 3, 4 problems. I'm going to read them to you quickly so you know what they say. So, there are 30 students in Miss Hall's class, and 6 students are not in class. Okay, so would that match 30 divided by 6 or something else? This one says there are 30 students in Miss Hall's class and 6 new students join the class. So would you do 30 divided by 6 to represent that, or something different? This one says there are 30 students in Miss Hall's class and the students are in 6 equal groups. Okay. Does that make sense to do 30 divided by 6? Does that match 30 divided by 6, or would it be something else? And the last one is, there are 30 students in Miss Hall's class, and each student brings in 6 plastic bottles. Whew, that's a lot of plastic bottles. So the question is, would 30 divided by 6 represent what that says, or would it be something else? Okay, so figure out which one it is. There's only one correct answer. If it helps you to draw a model, then please do that. And tomorrow I'll let you know which one's correct. All right. Good job, boys and girls. I know this is a long week with a lot of challenging work, but hang in there, okay? And we'll keep working on it throughout the year, all right? I'll see you later. Bye-bye.